Hello everyone, so this is problem number 60 from the chapter Center of Mass from book Verma. Here it is given that a small block is kept on a triangular wedge of capital mass M having an inclined alpha with respect to the horizontal. Okay, so it is kept on a frictionless surface. This height is h. This mass is small m. So here it is asking find the velocity of triangular block when the smaller block reaches the bottom end. Okay, so let that smaller block reaches the bottom end and it has a speed of v1 with respect to this capital M, and this capital M is going to move with the speed v2 with respect to ground. Okay, so what is the velocity of M? So it will be v1 cos alpha in horizontal direction and vertical direction v1 sin alpha. So this is the velocity of a small m with respect to capital M. So velocity of a small m with respect to ground is equal to velocity of a small m with respect to capital M minus velocity of capital M with respect to ground. So we will have v1 cos alpha minus v2. Let this be x axis and let this be y axis. So this I cap or x cap plus minus v1 sin alpha y cap. So this will be the velocity of the small m with respect to ground. Now let's consider the linear momentum conservation in x direction, because there is no any external force in x direction, so that we can say that m into v2 is equal to a small m into v1 cos alpha minus v2. So from here we can say that a small m into capital M into v2 is equal to a small m v1 into cos alpha. Let me write this as equation 1, 2 and this as equation 1. Okay, now the small block was kept at the height of h, so we can use the energy conservation also, that is total potential energy is equal to kinetic energy, that is half capital M into v2 square plus half a small m into v1 cos alpha minus v2 whole square plus half m v1 sin alpha whole square. Okay, so if you solve this equation, then you'll get m v2 square plus a small m into v1 square plus v2 square minus 2 v1 v2 cos alpha is equal to 2 mgh. Let me say this as equation number 3. So using these equations, you will get v1 is equal to m plus m into v2 by m cos alpha. So this is v1 from equation 2. So this is v1 from equation 2, and substitute the value of v1 in this equation 3. Then you will get, so by this substitution you will get v1 is equal to 2 m plus m into gh upon m plus m minus m cos square alpha. So this is v1, and v2 you will get, that is speed of the bigger block is m v1 cos alpha by the small m plus capital M, so that is 2m square cos square alpha into gh upon a small m plus capital M whole square minus m into cos square alpha. So this is the value which you will get after solving the equation. So this equation is quite difficult to solve, but it's not that much difficult also. Just substitute the value of v1 and definitely you will get this as your solution.